Today we're going to be doing a review of completing the square. Completing the square is something that we did first semester in the quadratic unit, but we haven't used it in a while, so let's review how to complete the square. The goal is to be able to write any quadratic as a perfect square. I'm going to write a quadratic, x squared plus 6x plus 9, as an example of a perfect square trinomial. If we wanted to factor this, remember that we need to find factors of that c coefficient, so in this case it's 9, factors of 9 that add up to the b coefficient, which is 6. What makes this a perfect square is that those numbers are the same. So factors of 9 that add up to 6 are 3. 3 times 3 is 9, and 3 plus 3 is 6. So then if I factor that, I end up with x plus 3 times x plus 3. Those two binomials are the same, and when I have the same thing multiplied by itself, I can write that as x plus 3 squared. That's what makes that red quadratic a perfect square, is that it factors into one binomial multiplied by itself. So let's go through the steps for completing the square. So if I have a quadratic, I need to isolate x squared plus bx and set that equal to whatever else you have in your equation. Our formula is x squared plus 8x plus 7 equals 0. I want to isolate x squared plus bx. In this case, b is 8. So to isolate x squared plus 8x, I need to subtract 7 from both sides. That gives you x squared plus 8x equals negative 7. The next step is to take that b coefficient and divide it by 2 and then square it and add that value to both sides. So add b over 2 squared to both sides of your equation. Our b coefficient is 8, so over on the right side I'll write 8 over 2 squared, which is 4 squared, which is 16. I'm going to add 16 to both sides of my equation. That gives you x squared plus 8x plus 16 equals 9. This is awesome because now the left side is a perfect square trinomial. So we're going to factor that left side. Factors of 16 that add up to 8. That number is 4. 4 times 4 is 16. 4 plus 4 is 8. This factors into x plus 4 times x plus 4. And that still equals 9. So you have x plus 4 squared equals 9. You could go ahead and solve from here, but I'm really just interested in this completing the square process, so you can go ahead and stop there. Our next example, I have the equation y equals x squared minus 10x plus 3. This is a formula in standard form. Let's say the question is asking you to use completing the square to write this in vertex form. And again, I'm more interested in the completing the square part than remembering those quadratic forms. So let's go ahead and isolate x squared minus 10x by subtracting 3 from both sides. Y minus 3 equals x squared minus 10x. Now that we have x squared minus 10x isolated, we can complete the square by adding that special number, b over 2 squared, to both sides. Our b coefficient is negative 10, so negative 10 over 2 squared is negative 5 squared, which is 25. So I'm going to add 25 to both sides. That turns into y plus 22 equals x squared minus 10x plus 25. We're almost done. Go ahead and see if you can factor the right side of this equation. So figure out what's a factor of positive 25 that adds up to negative 10. All right, so hopefully you figured out that our factor is negative 5. So that right side factors into x minus 5 times x minus 5, or x minus 5 squared. If I was going to write this in vertex form, I would need to get y by itself. So our last step would be to subtract 22 from both sides. And now we have that same equation that we started with, but now written in a different form. The next thing we'll do on Monday is use completing the square to write equations of circles in standard form.